Hello, how do we solve for x in this equation? Solution. Let's get down the question first. 5 to the power of x plus 5 to the power of 2x plus 5 to the power of 3x is equal to 155. This implies that 5 to the power of x plus 5 to the power of 2x could be written as 5 to the power of x times 2 plus 5 to the power of 3x could be written as 5 to the power of x times 3 equal to 155. Let's suppose 5 to the power of x is equals to k. This implies that, so anywhere we see 5 to the power of x, we just replace it with what? With k. So we have k plus k square plus k to the power of 3 equal to 155. Let's continue. This implies that k plus k to the power of 2 plus k to the power of 3 is equal to 155 could be written as 5 plus 25 plus 125. Let's proceed further. This implies that k plus k to the power of 2 plus k to the power of 3 is equal to 5 plus 25 could be written as 5 to the power of 2 plus 125 could be written as 5 to the power of 3. This implies that. Now, let us move each of these guys to the left hand side. So that will be k plus k to the power of 2 plus k to the power of 3 minus 5 minus 5 to the power of 2 minus 5 to the power of 3 equal to 0. I can actually rearrange this equation as this. Taking this first, k with this minus 5 plus k square minus 5 square plus k to the power of 3 minus 5 to the power of 3, everything equal to 0. It is possible I can put these guys in brackets, so that will be k minus 5 in bracket plus k square minus 5 to the power of 2 in brackets plus k to the power of 3 minus 5 to the power of 3 also in bracket equal to 0. Let's continue. Recall that a square minus b square is equal to a minus b times a plus b. Also recall that a to the power of 3 minus b to the power of 3 is equal to a minus b times a square plus ab plus b square. Take note of these two properties, very important. So from this line, we're gonna have k minus 5 plus, applying this second property to this guy, we're going to have k minus 5 times k plus 5 plus, now applying this identity to this guy, we're gonna have k minus 5 times k square plus 5k plus 5 to the power of 2, close the bracket, everything equal to 0. Let's proceed further. You will notice that in this equation, something is very common. K minus 5 is common. That means we can factor k minus 5 out. So that will be k minus 5 into, this become 1. That is, k minus 5 times 1 gives k minus 5 back plus k plus 5 plus k square plus 5k plus, what is 5 square? That is 5 times 5, 25. So we close the bracket, equal to 0. Let's continue. So we have k minus 5 into 1 plus, let's drop these brackets. We have k plus 5 plus, Let's drop this bracket also. We have k square plus 5k plus 25 equal to 0. Let's continue. K minus 5 times k square plus k plus 5k, that is 6k, plus 1 plus 5 plus 25, that is 31, equal to 0. Hope you got that. Let's continue. This implies that k minus 5 is equals to 0, or k square plus 6k plus 31 is equals to 0. Clearly, from this line, k is equals to 5. Take note of this. Now, let's consider this quadratic equation. We can solve it using quadratic formula. K equal to minus b plus or minus square root of b square minus 4ac divided by 2a. From this equation, a is equals to 1, b is 6, c is equals to 31. So we have k equal to minus, what is b? B is 6, plus or minus square root of b square, that would be 6 square, minus 4. What is a? A is 1, c is 31, into 1 into 31 divided by 2. What is a? A is 1. Let's continue. K is equals to minus 6 plus or minus square root of 6 square is what? That is 6 times 6, 36, minus 4 times 1 times 31, that is 124. Everything divided by 2 times 1, that is 2. K equal to minus 6 plus or minus square root of 36 minus 124, that is negative 88, divided by 2. Let's proceed further. K is equals to minus 6 plus or minus square root of minus 88, could be written as square root of 88 times square root of negative 1 divided by 2. So k is equals to minus 6 plus or minus square root of 88. But don't forget, from the complex number, square root of minus 1 is equals to I. So we have I here divided by 2. K is equals to minus 6 plus or minus. We can rewrite square root of 88 as square root of 4 times square root of 22 times I divided by 2. K equal to minus 6 plus or minus. What is square root of 4? That is simply 2 times square root of 22i divided by 2. K equal to, I can pull out 2 from this numerator. So we have 2 into minus 3 plus or minus square root of 22i, all divided by 2. K equal to, clearly 2 cancels 2. We are left with minus 3 plus or minus square root of 22i. This is another set of solution, that is k equals to minus 3 plus square root of 22i, or minus 3 minus square root of 22i. But our main goal is to find the value of x. Let's consider this first to obtain x. So since 5 to the power of x is equals to k, let me show you where we got this from. It's from this line, this assumption. Let's proceed further. So when k is equals to 5, this implies that we have 5 to the power of x equals to, in place of k, we write 5. This implies that 5 raised to x is equals to 5 could be written as 5 to the power of 1. This implies that Since the base is the same, that means the power must be equal. So x is equals to 1. This is the first solution. Now, let us consider this other value of k. Let's manage this side. When k is equals to this, minus 3 plus or minus square root of 22i. Let's separate this. Since 5 raised to x is equals to k, as we did for k equals to 5, let's continue. This means that 5 to the power of x is equals to, in place of k, we write this, minus 3 plus or minus square root of 22i. Let's take natural log of both sides. That will be log 5 to the power of x equals to log minus 3 plus or minus square root of 22i. Log 5 to the power of x could be written as x times log 5 equal to log minus 3 plus or minus square root of 22i. If we divide both sides by log 5, we have x equal to log minus 3 plus or minus square root of 22i divided by log 5. At this stage, let's recall a very beautiful property. It says log a over log b is equals to log a base b. Take note of this. X is equals to, applying this identity to this guy, we simply have log minus 3 plus or minus square root of 22i base 5. That is by comparing a is minus 3 plus or minus square root of 22i, while b is 5. So we have this. This implies that x is equals to, considering the positive sign, we have log minus 3 plus square root of 22i base 5, or x equals to, considering the negative sign, we have log minus 3 minus square root of 22i base 5. These are another set of solutions. So let's call this x1, the first solution, which is real, and let's call this s2 and this s3. These are the two complex solutions that we have, and only one real solution, which is x1 equals to 1. That's it. Thanks for watching.